It's impossible to build a software system without technical debt.
Yeah, you don't want zero. That's not a great objective, no. What are the main implications of technical debt? And not specifically for developers, but for the organization as a whole.
If the complexity is increasing, your development speed will go down.
And why do people zone out so quickly, saying, this sounds like a technical problem, this is something they need to solve in the software department, not my problem? Hi, welcome to the Signal podcast. This month's edition is an edition about technical debt, and our guest today is Ger Cloudt. Ger Cloudt is the author of the book What is Software Quality? Ger, can you introduce yourself?
Yes, my name is Ger Cloudt indeed. I have about 40 years of experience in development of software. I started as a software developer at Philips. Within Philips I moved to different parts of Philips like Holland Signalapparaten, automation of manufacturing, medical systems, semiconductors. Semiconductors became NXP. In the late 90s, I became a group lead, so I became in a management position, especially within semiconductors. 2015, I switched to Bosch, also in a management position, leading a team of software developers. That was also the period that I wrote the book. And 2 years ago, I decided to take a new challenge at ASML. And at ASML, I'm working as a software quality manager. And that's, of course, associated also to the book. It's about walk the talk.
Walk the talk.
Yeah. Walk the talk. And that's why I decided to make the switch to a software quality manager.
So it sounds like we invited the right person to talk about technical debt.
I hope so.
So I work as a delivery director at Software Improvement Group. I've done that for the past 12 years, and I've looked at many software systems. We're often invited to assess the quality of software systems, especially at larger scale, complexer software systems. And as such, you see a lot of technical debt.
Yes, I can imagine.
Yes, but you also learn that people have very different views on what technical debt really is.
Yes.
So I remember a client that saw all their Delphi code as technical debt. So whenever you encounter Delphi, that was technical debt that had to be removed. I also have clients that do a lot of development still in Delphi, where it's very important for their key business processes. So, and this is just a simple example, but they're very different views. So how do you see technical debt? How would you define it?
Well, I would like to start with an example which is completely wrong. I did a leadership training some years ago. And in that leadership training, it was especially indeed for leaders. Also, the subject of technical debt was addressed. And then the lecturer was explaining about features and backlog, and he was explaining about estimates and commitment of the team. And then he was showing on the flip chart a kind of earned value chart.
Yeah.
And of course, the earned value did not complete the complete backlog, and there was a small part of the backlog which was not delivered. And then he explained to the people in the training, well, this not delivered part, that's technical debt. So I was really flabbergasted. How can you think that not implemented features is technical debt? So I try to explain what it is. The definition I use in technical debt is, I consider technical debt as the accumulation of imperfections in the software, and then referring to design and to code. That's the definition I use.
Accumulation of imperfections. I think Ward Cunningham was the original, I think the person coining the term somewhere early in the 90s, 1992.
Correct.
I think he said it's when you make a conscious decision as a team to take a shortcut, knowing, even maybe planning ahead the moment where you will actually solve that. But right now you need some speed up because of a sort of business demands, which is fine. But then this is a sort of a design decision, and you revisit it. And you talk about it slightly more pragmatically, I hear, right? So it accumulates automatically.
It's also bigger, because I think that technical debt is also created not on purpose. So it's unintentionally also created. Like if you have, for instance, junior programmers, and they are creating non-perfect code. Well, you could ask the question, what is perfect code? And does perfect code exist? No, probably not.
No.
Yeah, but for me, technical debt is not only intentionally, but also unintentionally created. Yeah, and what you could do, for instance, is you could refer to the technical debt quadrants, which were introduced by Martin Fowler. And he thought about two axes. There's one axis in which you have prudent against reckless, and you have an axis in which it says deliberate against inadvertent. Yeah, and then you get 4 quadrants, and technical debt can be positioned in those 4 quadrants. And then especially the inadvertent side is unintentional. So for me, it's not only intentional, it's also unintentional.
Yeah. So would you... is it very objective to determine what technical debt is? Because I often end up in discussions also with developers or architects that have a very strong view about specific things being technical debt or not, where it seems like it's very hard to get to a sort of common ground on what technical debt is for them.
Correct. Yeah. And I think it's very subjective indeed, because people have different opinions about that. But if you use the definition of like it's the accumulation of imperfections, then the next question is, what is an imperfection?
Indeed, yeah.
Yeah, and you can imagine that for some people an imperfection is something different than for other people. So it's very subjective. And then I think if you look to technical debt, there are parts you can measure. Yeah, think about static code analysis. Yeah, you get all those violations, which is in essence is technical debt. You can measure that. But there are also many things which you cannot measure. Yeah, if you take the example of clean code, one important aspect in clean code is, for instance, the usage of meaningful names. So how to determine whether something is a meaningful name?
Sure.
Yeah, it's very subjective. And I think that's also a danger about if you're measuring technical debt and using tools like static code analysis, which I think you should use them. But you should be aware that when you use them, that you only measure a part of technical debt, and that's the part which is measurable, but you should also consider the part which is not measurable as such.
Yeah, it's always something subjective and
exactly
about software engineering, indeed.
Correct.
So what do you think, what in your experience, you've seen many different organizations up close, what are the main implications of technical debt? And not specifically for developers, but for the organization as a whole?
Well, for the organization as a whole, it's an increase of complexity. If you look to complexity which teams are facing, then they are facing 2 kinds of complexities. One complexity is imposed on the team. It's the solution, it's the problem they have to solve. And that complexity, like I said, is imposed on the team, so the influence of the team is limited. Yeah, they have to solve the problem. But there's a second source of complexity which they create themselves, and that's the internal complexity. And basically, that's the accumulation of those imperfections. Think about creating code which is hard to understand. Yeah, then you are creating imperfections and increasing your internal complexity. And you write the code today, but you will be facing it tomorrow. Yeah. Another example is about dependencies, because if you look to complexity in software, it's very much about dependencies and about obscurity. If you create a bad design and you have a lot of unnecessary dependencies, then your complexity is increasing. And that's the consequence for the organization, because if the complexity is increasing, your development speed will go down. So I think that's one of the main implications for the organization itself, that your development speed will go down.
Yeah, I really recognize this dual layer of complexity. So I often encounter very complex domains where people build very complex software systems to address those domains, even intentionally, thinking it's hard, so the software system must also sort of be a copy of that hard domain. But if you have a complex domain and you build a complex system, you have 2 problems.
You have 2 problems.
And what you want is a very complex domain with a very simple, nimble, agile, if at all possible, system to address all that complexity that you already inherit, that's bestowed upon the team.
Yeah, well, I always say that the internal complexity, the good thing about the internal complexity is that we are in control.
Yeah.
Yeah, and sometimes we decide to take a shortcut, but then we increase the complexity, but then it's our own decision. Yeah, and the complexity imposed on the team, we are not in control, and that's the difference.
Yeah. So at least take under control what you have under control.
Exactly.
I like that. So one way of talking about technical debt that I really often use to make it hit home at the management level is that it is one of the sides of productivity. In the way that if you have a lot of these accumulated inefficiencies, of course, the end result is that if you want to make a change to a system, it will take either more time, more money, or more people, however you want to measure that. But it's always going to cost you more and limit your productivity. Do you see that connection also?
Yes, that can I see it because productivity, of course, is associated to the development speed.
Yeah.
So I see that connection indeed. Yes.
And again, I look at many different software systems, and whenever you measure a software system, you're always going to find stuff. You're never going to find a sort of a perfect solution that doesn't really exist. It will be prohibitively expensive for a company to actually have such a system. So it's typically full of technical debt. And if you ask developers, what is your favorite problem that you would solve? Not your favorite problem. If you would have a little bit of time, where would you start solving things? They always have an answer. Like given a sprint, given an hour, given a month, I would really refactor XYZ because I think that's relevant. I would claim if you zoom out and you have very limited refactoring budget, let's say, if it even exists, but let's assume there are a few hours left, that it's probably not best spent asking a particular developer, but stepping more and more back, looking at the whole, and then probably there are only a very few pieces of technical debt that actually give you a productivity improvement. So you shouldn't ask an individual developer. You should actually try to inventorize on a higher level. I wonder if you encountered something along those lines in your experience.
Yes, I did. Yeah. And I agree. And I would like to make it more concrete. So an example I'm using to explain this is that when I'm talking about technical debt and whether you should address it, I always tell people you need to put it in context. And then the next question is what context? Well, the context of my future roadmap. And what I mean by that is suppose we have this function sitting in the software with a very high cyclomatic complexity. Yeah, and that's typically a candidate to refactor to decrease the cyclomatic complexity. But then my question always is that function sitting there, is there any reason it needs to be changed? Yeah, and any reason could be we have to solve a bug, or a reason could be a new feature is kicking in, and for that new feature we need to make a change.
But not there's a more beautiful way to do it.
Exactly.
Which is the aesthetic argument.
Exactly, yeah. and that's the connection to the business. If this new feature is kicking in, which requires a change in that function, then my recommendation would be, yes, please address the technical debt, because you will gain it back whenever you implement that feature. But if there is no business reason to change that function with a high cyclomatic complexity and it's sitting there already for several years, keep it as is and don't touch it. And from that perspective, I think that it's good when teams make an inventory of technical debt they know. It's like a backlog. And then my recommendation would be, whenever you think about the next release, take your backlog and review the technical debt backlog in the context of your product backlog, and try to make a connection which of these technical debt items are really affecting my development speed for the features which are prioritized on the backlog. And then you can answer the question whether you would like to refactor them, yes or no.
The approach sounds fine, but to me, I would be interested in making such an inventory of technical debt. Isn't that obsolete by the time you've finalized the inventory? So how do you make sure that is in sync with your code base?
It's not obsolete. It will change. Yeah, because whenever you have a backlog with technical debt items and you fix one, then you have to remove it from your technical backlog. And also it might require indeed a regular review of that backlog.
And do you see teams doing this? You see teams even struggling writing documentation. And so the common interpretation of the agile principles is no documentation, which I don't think is literally there, but that's how it's taken. So that's already hard work. Then can you imagine, do you see teams also actually making such an inventory of technical debt?
Yes, that's what I see. Yeah, but the next step to review it on a regular basis and to take it and to take it in the context of the product backlog, that I only saw once. Yeah, so
relatively rare, I would say. So, but then
yes, relatively rare. Yes.
But so, where do you think the responsibility should lie? Because I often think the development is always retroactively they get all these responsibilities. Security problem, you should have made it secure. Yes. Resiliency problem, you should have made it resilient. A technical debt inventory, you should have kept that up to date and checked it all the time. I would say maybe other people inside the organization and maybe also more senior management should be involved, not in making that list of technical debt, but in making sure that these things exist and happen, and also that they are clear about the roadmap, for example, so that you know better how to actually test items on
Yes.
a technical debt list. Do you see that happening? Do you see changes there?
Well, what I think is important, I think as software professionals, we should take our own responsibility. And that also implies that sometimes we have to say no. Yeah, because we have a responsibility to deliver high quality software. That's one thing. But next to that, if you compare that with the responsibility of an organization, I believe that an organization has the responsibility to provide the engineers with an environment in which they can take their responsibility, if you understand what I mean.
Does it mean that they get do you mean it in the sense that they feel the safety to make mistakes and try, or that do you mean in that they get far more clear guidelines on what they actually need to adhere to non-functionally?
I think it's both, yeah, but it starts with a safe environment, but it starts with what you see in a lot of companies and organizations is a strong focus on feature delivering. Yeah, it's important to deliver that feature, and then to enable that and to make the deadline, shortcuts are made and stuff like that. And I think an organization should provide the environment in which the engineers can deliver that quality, and they also feel they have sufficient room to deliver that quality. Yeah. And if you're as an organization only talking about speed and you're only talking about features and deadlines, then you will get features and deadlines, and then people forget about quality.
Yeah. Yes, I'm interested in your claim that as software professionals, we should be responsible for delivering high quality software. That sounds like a lofty objective, like something indeed.
Yes.
So we must bring the engineering to software, else it's not really software engineering. But it's also true that if you want to build a software system that is highly resilient, highly performant, highly maintainable, has a great extensible architecture, that's unaffordable. And so if you make no trade-offs in quality, then you essentially go bankrupt. It's impossible to build the perfect software system, as you already alluded to earlier.
Correct.
Is it up to developers to make that decision? A little bit more security, a little bit less performance?
Yes and no. What developers do need to do is of course, it's dependent on in what area you are working. Take safety critical systems, then the quality standards have to be much higher.
Sure, yeah.
But if you are building a prototype, of which you know it's only a proof of concept, then your quality standards can be lower. You only have to show that it can be done. Yeah, that's a completely different. And somewhere in between, you might have a consumer electronics product. Yeah, it doesn't need to comply to the quality standard of safety critical systems. And that's where it starts. I think where it starts is having the discussion with your organization, where do we want to be? Yeah, and then indeed, do we want to be at a quality level of safety critical systems, or do we want to be at a quality level of consumer electronics or something like that? You need to have that discussion and you need to make that explicit. And within that context, if that context is provided, sometimes it's quite obvious. If you're developing software for a TV, then you know it's consumer electronics. But then still you can have the discussion with your management. So what do you consider as quality standard for this product? Yeah, you can imagine that a Philips TV might have a higher quality standard than a B brand, which you can buy at a Praxis or something like that. So you can have that discussion, and you can also have that discussion. What does that mean for our practices? Yeah, so it's not like that I'm advocating you need to build perfect software. No, of course not.
No.
And another thing I would like to add, if you think about technical debt, in general, technical debt is considered as slowing down because it's increasing complexity. And many people also say technical debt is something bad, so you need to mitigate it as much as possible. I think people should also realize that technical debt can be something very good. Yeah, it can serve a purpose. Yeah, and that's for instance in the situation that you have a manufacturing plant and your manufacturing is stalled because of a software error. Well, it costs your business millions of euros. Then you need to get the factory up and running, the production up and running as fast as possible. And then I don't care whether you put in a high quality solution or low quality solution. Just get it up and running.
Higher objectives.
Yes, and then if you put in a dirty hack, fine. a dirty hack goes into the system, manufacturing is running, and I introduced indeed a piece of technical debt. But then the question, of course, is whenever manufacturing is running again with this piece of technical debt in my software, am I going to correct it in a proper way again?
Do you get, well, I think most developers would like to. I think most developers know full well where the sort of the challenges are in their application, their landscape. It's mostly, do you get the freedom?
Correct.
And my suspicion is in your hypothetical factory here that somebody is pushing a backlog full of features and says, well, the factory is working. Can you please start adding new things?
Correct.
So you talked about this dialogue earlier,
Yes.
right? So do you see that the dialogue happening? And
No, not sufficiently.
so what could we do to facilitate that dialogue, to get it started? Is it something that developers must sort of drop down the work and say, we must speak? Is it something that needs to be facilitated by people in your role at technical management? Or is it more non-technical management, so people more responsible for the overall organization that see, hey, this is a something that's slowing me down, a potential risk for the future that I need to address? Where do you think the dialogue should come from?
I think it should come from all of them. So, of course, as a quality manager, I have a role in that within my own organization. But also the engineers themselves, they also have a role in it. And it's really starting the dialogue, but also trying to visualize it. Yeah. So what I mean by that is try to create transparency.
Yeah.
And sometimes, just another example, if you talk about bugs in the system, bugs are registered in Jira. And sometimes I do ask the question, do we know how many bugs we have? And not everybody knows. And also in management. And then you can make visible how many bugs there are. And then the next question is, how many bugs do we think is healthy to have or unhealthy to have? Yeah. And at least there is no black and white answer to that. And I also don't know whether it should be 20 or 50. I don't know. Yeah, open bugs. That also depends of the criticality of the bugs and that kind of stuff. But by starting the discussion and showing the numbers, you can create awareness. And if that awareness is there, then I think there's also a way to start a discussion. Shouldn't we fix more bugs? And then sometimes indeed it is decided, yes, let's fix some bugs. Let's create a downtrend instead of an uptrend. Yeah, and the same applies to for instance, did we test sufficiently? Like, can you show anything about coverage? Yeah, at least to support whether you tested sufficiently, because that's related to the bugs, of course. Yeah, and so it starts also with trying to make things transparent as much as possible.
Yeah, testing is also a very interesting topic. I think we often still encounter the view that testing is the functionality delivered, and so very often software is still built or procured from external suppliers. And there's not one line in the contract, or not one word said about test coverage. And to me, it sounds then like the person writing this code is essentially asking you to see whether it works. I think asking for a proof of work, also knowing that the system will work for you, maybe for 5, 10, 20 years.
Yes.
We all know systems that people wanted to get rid of for years, but they still run a business.
Yes.
And they're typically very old. If you have that test coverage at a nice level from the beginning, that's 20 years of benefits right there, just writing the test code. And it's really not the norm. I don't know if you see it differently, but I'm still very surprised by how little test coverage you actually see in practice.
Well, yes, I agree with that. And next to that is that most organizations even don't know their test coverage.
No, indeed. Yeah.
And if you look to code coverage, well, most organizations and teams know, because that can be measured relatively easily. But if you come to the higher levels in your test strategy, like the functional testing or the requirements coverage, that's a problem in many organizations, because they don't have the horizontal traceability.
Or the interest. You say words like bugs.
Yes.
And I already see some managers that I've seen in the past few weeks going, oh, bugs, I'm going to now read my phone because I heard the word McCabe complexity.
Yes.
And then they tune out. Whereas, and we talk about unit test coverage, and some people might think this is a very technical conversation. But the consequences of not having proper test coverage is that you have issues in production. It's a very simple thing, a very clear link.
Yes.
If you look at large, so on average, I would say larger organizations, larger mature platforms, about half of problems that you find in later areas of sort of later layers of testing, and sometimes there are many layers just for the fact that so many defects drip through, about half of the findings are code related.
Yes, correct.
Just code things that they could have done earlier. So it's very easy shift left examples.
Yes.
But the consequences are really senior management problems, outages in production, clients not being able to access systems. So this conversation very quickly jumps from test coverage to losing money in operation. There's a very short... But why is that so unclear on a management level? Why is that link so hard to... And why do people zone out so quickly, saying, this sounds like a technical problem, this is something they need to solve in the software department, not my problem?
Well, that's I don't know. Maybe it's a piece of interest. Yeah, maybe it's that we are not good enough in explaining it. That might also be the case.
Sure, yeah.
Maybe it's about short-term focus. Yeah, that testing also basically is bulldozed to later stages.
Yes.
So shift right,
Yeah.
and then we think about to correct it, and we call it shift left. Maybe it's indeed the case, like we need to make the deadline, so let's postpone the testing, and then we do a risk assessment, and based on the risk assessment, we say yes, we go.
Yeah.
And then later on, we go, and then the risk is materializing into a problem, and then we deal with the consequences.
Yeah, we'll see it then.
I think that's part of it. Yeah, the short-term focus to be able to make the deadline, I think, is so important and is also so valued within organizations. So I would tend to go in that direction.
Oh.
Yeah.
So we've covered a whole bunch of topics. What would you give as sort of takeaways, sort of key points about technical debt that we should really remember?
What we really should remember, that technical debt is inevitable. So it's impossible to build a software system without technical debt.
Yeah, you don't want zero. That's not a great objective. No.
Correct. So it's inevitable, and it's increasing the complexity. And by increasing the complexity, it will slow you down.
Yeah.
And the consequence of that is that you have to find a good balance in handling technical debt. And that doesn't mean that you only need to handle technical debt. No, you need to find a healthy balance. There was a study done at, I think it was the University of Oslo, and they did a study in companies, big companies, how much time they spent on managing technical debt, and they came to the number of 25%. And that sounds...
Indirectly. Not even knowing that they were dealing with it is what you mean.
No, they were knowing they were dealing with it, but you have different maturity levels on how to handle technical debt. You have organization in which it is not managed.
True.
Still, some
definitely.
engineers take the responsibility, and anyway they fix things. Yeah. But you can also go up to a maturity level in which where indeed technical debt is measured, where a backlog is created, and where the backlog is managed, and indeed where time is allocated to solve technical debt. And all of those stages of the different companies, and they were distributed over those stages of maturity. Yeah, but they came to the number of 25%. And that sounds quite a lot.
It sounds a bit high. Yeah.
Yes.
All right, so we still have some work to do.
We still have some work to do.
This is not a solved problem.
It's not a solved problem, no. Right. And I think it will not be solved in short term either.
It was a very nice conversation. So I briefly still want to talk about what you wrote, because you feel so strongly about this topic that you... this is the second edition, I think, already of your book.
Correct.
So what did you extend the first edition with? What are the sort of the additions that you had to make?
Well, I can give you one example. If you look to the book, then on the cover, this is what I call the 1+3 software quality model. Yeah, and it consists out of 4 quality types. On the bottom, you have product quality, code quality, design quality. That's about the software itself. And on top of it, we have organizational quality. And organizational quality is defined as the capability of an organization to develop high-quality software, like craftsmanship, processes, skills, culture, infrastructure, everything which is enabling, what we discussed previously, which is enabling the engineering community to develop high-quality software. And if that is not okay, then you could replace the word enables by disables. Then even the bottom quality types are not possible to create.
It's even conditional, I would say.
It's conditional. Yes, it's conditional. To give you an example, the first edition, I published it in January 2021, and there was a quality manager at Philips, and he sent me a message, and he said, well, I didn't read anything about CMMI and ASPICE.
Oh.
And I thought by myself, it's about processes. So why didn't I wrote too much about processes in my first edition? And I thought by myself, because I have an opinion about process versus skill. Yeah, and I think that in the 90s we had this period in which the CMMI was very important, and the software CMM, and all those companies were focusing on becoming level 2 and level 3 in software CMM.
For their tenders, yeah.
Yes, exactly. And it was all process focused. And I had the feeling we are forgetting about craftsmanship, because I think craftsmanship is more important than process. Because if you don't have the skill, a process will not help you.
It's a bit of a distraction even, then you're focusing on getting to that level 5. Yeah?
Exactly. That was my point. And I thought that also, because that's how I consider process and skill, that might be the reason that I didn't put it in my first edition, because I value craftsmanship more than process. On the other hand, process is important, so I cannot neglect it. So I added it in the second edition. So that's one example of what I added in the second edition. And I think another interesting chapter I added in the second edition is also about infamous software failures. Yeah. So I had a look at some software failures, like for instance unintended acceleration of a car, the Mars Climate Orbiter, the Boeing 737, the Millennium Problem. So I also spent a complete chapter on those for software failures, basically to show that you can have so many different kind of software errors with so many different consequences. And I think people need to understand that. So that's another edition, for instance, in the second edition.
Makes me think of this famous software failure with this, was this MRI scanner, or there was this radiation device?
Yes.
And I think I took and there was something wrong with the I don't know if you write about it. I didn't see
it.
No,
that one is not covered in the book, but I know there was indeed a problem with radiation, and that's safety critical, of course.
Yeah, the levels became too high, and it was a software mistake, and then of course the insight was it takes 13 years to be a radiologist.
Yes.
And it takes no years to become the software developer who makes a first attempt at writing the software that controls the radiation in the device.
Yeah, exactly.
So it plays often a more fundamental, often when the bridge doesn't work outside, that's often a software failure. That's not known.
Yeah, correct.
It's not seen as that, and it's not perceived as that, but it's definitely just a software challenge. Yeah. Very interesting, Ger.
Thank you.
Thanks a lot.
You're welcome.